So I'm just going to quickly go over my function, my transform.py. So for shift, this basically shifts the image so that you shift the original image and find an overlap between the shifted version of the image and the original image, and it actually returns the shifted image. For automatic contrast, it finds the darkest pixel in the image, the brightest pixel in the image, and scales it to 255 value. The darkest would turn out to be black, the widest would turn out to be 1. For better color mapping, I find the channels and multiply each of the channels by some constant to kind of tweak the color settings a little, and it results in a better looking image. For crop center, basically I was having some issues with the alignment, so I cropped the top, bottom, left, right sides of the image by 8%, and it resulted in better alignment. For brute force, basically it goes through the search radius, computes the overlap, I'll go over this later, and then finds the score, then finds the best displacement, brute force basically. I'll go over this one later. For compute overlap, basically if the shift is positive, then for the first image we want to start at the shift and end at the height. For the second image we want to start at 0 and end at h minus the height, and vice versa. For if the shift is negative, then we want to start at 0 and end at h plus dy, start at negative dy, end at h, and same thing for x. And so this just computes the overlapping regions. For zero normalized cross correlation, we find the two regions. So this is the region of image 1 that it overlaps with image 2. This is the region of image 2 that overlaps with image 1. We calculate the mean, subtract the mean from region 1 according to the equation in the handout, then sum the norm region 1 times norm region 2, and we divide by the norm, and the actual score is numerator divided by denominator. So if the score is closer to 1, then the images are better aligned. Finally, for the estimate translation pyramid, we have max level 6. This is the base case. So if it's 0 or if the image is too small, then we just do the base case implementation. We want to do Gaussian to reduce aliasing, then take downsample every other pixel. Then basically once the recursion starts unraveling, then this would be our initial guess. We want to scale the guess up every time, and we start this as our initial guess at each level. And in similar logic to the brute force, we compute overlap and find a zero normalized cross correlation. So I'm actually going to run this just to show that it works. Yeah. And so while it's running, I'm also just going to pull up my hero image for you to see. And in my implementation, I found that the speed-up factor was around 13.5. If you use brute force versus multi-scale on one of these TIFF images. Yeah. So it's still running. Yeah. And each of these TIFF images takes around 8 seconds, but if I used the brute force, it would have taken 2 minutes.